Hey guys, to illustrate rotational symmetry, I found this video. It's written for grade 5, so it's a little bit less difficult than what we're looking at, but it does a pretty good job of explaining to you what rotational symmetry is. So I want to play this for you and then we'll move on from there. This is about rotational symmetry.
Order of rotational symmetry, Level 5, Grade E, GCSE. Okay, rotational symmetry is the lesser known cousin of line symmetry, which most people are familiar with. But with rotational symmetry, what we're interested in here is how many times does a shape turn on top of itself in 360 degrees. So if we just look at this 5-pointed star shape, if you're familiar with this idea, then you're probably going to guess how many times it will fit on top of itself, but let's go through it. So if I turn it around, there it fits once, twice, 3 times. It's not perfect because it's not rotating perfectly, but it's good enough. 4, and back to the top 5 times. So if all the sides are the same, all the angles are the same, it's a regular shape, then it will just fit on top of itself however many pointy bits it's got. So this is order 5 for rotational symmetry. Okay, let's have a look at some other shapes. Once you've seen a few, then you can get the idea. This is not very complicated, but just got to know what it means and how to say it. So a square, if we spin that around once, twice, 3, and obviously 4 times, so that's order 4 of rotational symmetry. And then we've got this hexagon, and let's actually just mark on a point on that because it's not quite so obvious. So on a hexagon, you probably think it's going to be 6. Let's just check it. Once, twice, 3 times, 4 times, 5 times, and back to the top 6 times. So order 6. Now this can be quite easily tested. If you've got a piece of tracing paper and do what I've done there, just put your pen in the middle and spin it around, you can see how many times it fits on top of itself. This last shape though, it's a triangle, so it's got 3 sides. You may think it's 3, but it's not a regular triangle, so you might realise that it's not going to be 3, but we'll just show you. So as I spin it around, it doesn't fit anywhere around there, or around there, or around there, but it does when it gets back to the top. So once in 360 degrees. If it fits, it has order 1, then we say it has no rotational symmetry. Okay, so if it's order 1, it has no rotational symmetry. We don't put order 1, we just say it's no symmetry. Let's try and spell that right. So no rotational symmetry. Okay, so there we go. Rotational symmetry.
Okay, hopefully that helped to explain a little bit better about what that term means. All right, we got one more, and that is a periodic graph. We already touched on this one when we did the one that repeated itself. So a periodic graph is a graph in which one piece repeats over equal intervals. And rather than have you draw that again, I'll just go back and show you. It is this sort of graph where it repeats in equal intervals over and over again. That is called a periodic graph. Very common in earth science, even in the waves of the ocean. You can see that periodic repetition. Okay, that is the end of the terms that we have to do, I do believe. If I have failed to cover any of them, please send me an email. Let me know, and I will go back and make sure that we have them all. But you have a very full glossary at this point. You have learned a lot of new terms, and hopefully you know them better than just reading them. I hope that they mean something to you at this point. Um, okay, I'm going to stop the video. I'll start it up again and we'll do the exercises in your workbook and also the unit review.